Hi, this is EPFL Xplore. My name is Nour Larbi and I'm the president of EPFL Xplore, a student-led space robotics association that is part of the MAKE initiative at the Swiss Federal Institute of Technology in Lausanne, EPFL. Our association brings together 120 students dedicated toward one mission, training the next generation of engineers through hands-on space robotics projects. Our activities are organized into three main divisions. First, we have our educational initiative, the Explore Rover Challenge, ERC. This year, we are hosting the third edition of the ERC competition on campus at EPFL, where 10 mini rovers compete through tasks inspired by the European Rover Challenge. With this training, students develop the skills needed to then join our ERC pool, which is the team responsible for building our competition rover and drone. Finally, for students interested in pushing space robotics even further, Xplore Research focuses on more advanced and innovative projects in collaboration with labs and academics. This year, our competition team participating in the European Rover Challenge brings together 40 students organized around a clear technical structure. The project is led by our Vice President and Project Manager, Matthias Jones, together with 3 system engineers responsible for the electronic, the mechanical, and the software engineering. Under their supervision, the software division includes 3 team leaders responsible for the rover's navigation, the control station, and the handling device software. The mechanical division is composed of 2 team leaders responsible for the rover structure and the handling device hardware. In addition, dedicated team leaders oversee the drone development and science integration, while the electronics team manages power system and avionics. This organization allows us to efficiently coordinate both the development of the drone and the rover for the competition. Beyond the technical side, our association is supported by a management team responsible for logistics, communication, finance, and sponsorship, helping us both expand our outreach and technical capabilities. This year, we have been developing the 6th generation of our rover and drone, and we are proud to introduce Polaris and Nox. Building on the experience gained through 5 previous participation in the ERC, we are excited to take on the challenge once again. Every year, this competition pushes our team to learn, improve, and grow. It also gives a new generation of students the opportunity to work on exciting and meaningful engineering challenges. We can't wait to meet once again with the passionate students competing in the European Rover Challenge and to feel the thrill and excitement that make this event so unique.
Our new rover and drone systems, Polaris and Nox, are built on last year's strong foundation and are designed with new upgrades in order to increase performance, allowing them to achieve their objectives reliably and in challenging conditions. The biggest visual change is Polaris's new chassis. Departing from aluminium extrusions, the new chassis is made of welded aluminium sheets, allowing for increased modularity and a 50% weight reduction compared to last year's design. This new chassis allows us to separate the power system from the avionics, reducing the possibility of interference on measurements. In the middle of the rover, there is a new storage bay that can open and close in order to limit cross-contamination from airborne particulates. This compartment is used to store and weigh the different samples the rover will collect during the mission, and to store the tools the robotic arm will need depending on the task at hand. The 6 degree of freedom robotic arm is mounted with a tool changer mechanism that allows the end effector to be swapped in situ without intervention. This allows Polaris to select different tools depending on the situation, increasing its versatility and mission effectiveness. A depth camera located at the end effector is used to locate and collect rock samples autonomously, and also allows the rover to segment and locate components located on the control panel for autonomous actuation. Learning from last year's difficulties, the onboard drill has been upgraded with a new gearbox, increasing torque output from 2 Nm all the way to 16 Nm. This 30-fold improvement allows Polaris to collect subsurface soil samples deeper than 30 cm in compact and rocky soils, which can then be stored and weighed in an actuated storage compartment hidden underneath the chassis. Improved ride smoothness over complex terrain is achieved through a combination of flexible composite wheels, a passive suspension system, and a rocker bogie differential. This smoother ride enables improved autonomous navigation, with data from the onboard LiDAR, IMU, and cameras all fused together to increase localization precision and obstacle avoidance capabilities. Polaris's drive mechanism allows for a full 360-degree rotation, enabling omnidirectional movement and allowing the rover to climb steep slopes. At the heart of the rover is a new avionics system based on micro-ROS pipeline. It simplifies data transmission from the avionics subsystem to the ground station and allows for easier future integration of additional sensors. Two onboard computers share the computational load, enabling the deployment of more demanding algorithms and increased fault isolation. The control station allows for full real-time control of Polaris and displays the key data such as system status, motor currents, battery charge and sensor readings. It is also capable of initializing autonomy pipelines and activating a dedicated shutdown protocol if necessary. Safety is paramount at Xplore. The rover is equipped with an easily accessible emergency kill switch that can immobilize the system in under a second, while an LED status indicator allows nearby personnel to monitor the rover's current status and anticipate its next move. Our new drone, Nox, is a fully custom-built quadcopter capable of autonomous flight and is equipped with a camera, depth sensors and OptiFlow. For safety, the drone can perform an emergency landing in the event of a signal loss or at the request of an operator via the ERC controller or ground station. To further improve perception, Nox also features a 2-axis camera gimbal and a small LiDAR. Finally, no Mars mission will be complete without a scientific objective. This year, our science team is investigating the erosion phenomena that have sculpted the Hellas Planitia region over time. To support this, the rover is equipped with a custom-built microscope to analyze soil granulometry and identify the main erosion processes at play in the region.